All right, guys. What I'm going to do right now is just talk you through the exam answers. I've got the exam here on my right. I've got the answers here on my left. I'm just going to go through, probably note some areas as well where we all kind of went wrong. So the first question here was just asking you to calculate the circumference of the circular end of one silo. So it's just asking you for this. A lot of us just went 2 pi r and we got it right. That was one that I'd say like everyone got right. It's a pretty straightforward one to do. So that was 5.3 times by 2 times by pi. Right. Next question is show that the surface area to be painted on the front half of one silo is approximately 350 meters squared. Where we went wrong with this is we actually added this here, the 0.75, into our calculations. All right, and when we went wrong with that, that obviously led to a chain reaction of us having too much for the surface area of the whole silo. And then when you divide it by 2, it's obviously too much again. All right, so that was why a lot of us got that one wrong. All right, which whereas here you go 300, the surface area equals half of 33.3, which is what we determined this was, times by 22 minus 0.75. In question here, 3, calculate the total surface area that will need to be painted on the front half of 4 silos if 2 coats of paint. Okay, where we went wrong is we didn't read the question. So front half of 4 silos, okay? That wasn't noted either, and 2 coats of paint. So all we needed to do in this section was literally times 350, all right, by 4 by 2. All right, and that would give us our answer there. All right, in here, calculate how many 15-litre cans of paint will be needed to cover 3,000 meters squared. All right, that's really easy. 3,000 divided by 12 divided by 15. Okay, that will give you 16.67, which we see here. All right, and we're not going to buy 0.67 cans. We have to buy 17 cans. All right. The community purchases 16 cans of paint. Using your answer in part A3, show with the calculation whether this is reasonable. Okay, so that's asking you for this answer here. So 2,800. All right. Calculate whether 16 cans of paint is reasonable. So 16 times by 15 times by 12 equals 2,880. All right. And that is more than a reasonable buffer because you have 80 meters squared left over with that paint. All right, so you just calculate that, throw it in there. All right, question 2. This is one that stumped a few of us as well, so we're going to go through this a bit more. So calculate the area of the triangle. We have the height there of the triangle, all right, and we've got the base. So it's height, half the base times by height, and that would give us 33.15 meters squared. Show that the length AC is 12 meters. Well, we've got these two here, and we've got this right angle here, which means that AC, so this distance from here along here, is a hypotenuse of a right angle triangle. So we're going to use Pythagoras' theory. Most of us did that correctly. All right, here, show that the length EF is approximately 4.7 meters. All right, EF is here. All right, we know that this is 6 meters. Okay. Yep. And then 7.6 is here. So we need to find this. We know that this is 6 meters. EF is here. So we are using the inverse of Pythagoras' theory. All right. And that gives us 4.7 meters. All right. Just carrying on, you can blame that pause in Jack Tilley because he didn't read the sign on my door saying please do not disturb. All right. Calculate that the angle CED, okay, so CED, so that's this angle here. We know that, rule with triangles, all angles add up to 180 degrees. It gives you 28 degrees here and 113. So this angle equals 180 minus 113 minus 28. Okay, as you can see here, gives you 39 degrees. Okay, most of us, once we remembered that fact around number of angles in a triangle, number of degrees in a triangle, we were fine. All right. Using your answers to part CI, so that angle, calculate, show that the length DE, so DE, this length here, is 3.9 meters. So that's where we're using sine A, the sine rule. All right, so you've got here, thing that we need to note with it is with our sine rule, all right, we're trying to work out this length here. All right, 28 is opposite this. Okay, so that's why here you've got 28 and DE. And 5.2 is opposite what we now know due to this answer of 39. Excuse that terrible writing, I'm trying to use my cursor. All right, so that's why it is 5.2 over sine 39 equals DE times sine 28. That's our sine rule. Okay, and we just go through that process. We times this by sine 28. That gives us 3.88 or 3.9 meters. Using the answers, so using the answers from B and C, calculate, and the information in the diagram above, calculate the area of the trapezium. So we've got this trapezium here, wants us to calculate it. All right, area of trapezium is 12, all right, which is this distance here, plus 3.9, this distance here, over 2, times by the height. As we've found out already, this height is 4.7, and that will give us 37.37 meters squared. Most of us, because we struggled here, it didn't lead us to get this part done correctly. All right, we probably had these bits done right, but this bit really stumped us, these two questions. All right, so if you got these two wrong, you really need to focus on making sure that you get your trigonometric ratios down pat a little bit more. All right, show that the total area of the bunker is 70 meters squared. Well, you've got the area of a trapezium here, and you've already worked out the area of a triangle. So that is why we're just going to add them together, and they approximately equal 70 meters squared. Explain if the mathematical processes used would give a reasonable estimate of the area of the bunker. All right, it would be a reasonable estimate, but it might be a slight overestimate because most of the outlines of the shapes are outside of the boundaries of the bunker. All right, so you have a look here. A lot of the outer shapes are outside of these shapes, that like outside of the bunker. So you've got this space here, you've got this space in here and here. All right, it's not actually the bunker, so it's going to be an overestimation. Okay, this one here is a little bit tricky, but if you just follow the formulas that I've given you on the cheat sheet, it's really straightforward. Okay, so we know the total area, all right, and the volume equals area times by depth. It gives you that depth there. So we go, okay, volume times depth, that gives us 14 meters cubed. All right, we now need to work out how much sand is in there, all right, and for us to work out the sand, the mass of the sand, we times the density by the volume. Okay, it gives us the density here, and we times that by the volume of 14. That gives us 20,188. Okay, then we just, next step is just to divide that here by the number of, by the amount of sand the truck can carry, all right, per trip, 2,700. Equals 7.48 trips. We can't make 0.48 of a trip. We have to make a whole nother trip, so it's 8. All right, this question. Some of us did really well in this question. Some of us didn't. Okay, some of us, I think what stumped us here was this part of the question here, the hemisphere of ice cream. Okay, remember a hemisphere is half a sphere. We did not go through this process and then divide it by 2. A lot of people, right, so you see here, we've got half of the volume of the sphere. A lot of people just left that out, and this number was just slightly higher. A lot of people got around like 1.9, or some people got over 2. All right, so that's where we just need to be careful with that. Again, when they give you the formulas, they're doing it for a reason. They want to help you out. Make sure you fill in the correct numbers. All right. Again, here we go, density. All right. The ice cream Charlie will use has a density of 540 kilograms per meter squared, per meters cubed. State if the ice cream Charlie uses will have a mass of more than 1 ton. Justify your answer. All right. So here we times our density by our volume. We've got the density here, and we've got the volume that we figured out here. Times those two together, you get 874.8 kilograms. So no, he will not need 1 ton of ice cream. He'll need less. Okay, our next question. This is actually one that we all did really well in. So stats. Everyone, I think, besides maybe 1 or 2 of us, got this table right. So awesome job. Where some of us went wrong is we would actually just draw the box and whisker plot, and we wouldn't put our numbers on the box and whisker plot. All right. So when we're drawing them, if we have to do that in the exam, you have to make sure that you put those indicators there. All right. State one conclusion that can be made about females in 2018 compared with males. All right. We look at the data. In 2018, generally speaking, women have a higher life expectancy than males. Using statistical measures to support your answers, explain whether females or males in 2018 have more variability in their life expectancy. All right, this is where it's asking you to compare apples with apples. A lot of us said, well, females have we just spoke about females data and then we spoke about males data. I want you to compare the same measures of data. So IQR for females is greater than the IQR for males. The range for females is greater than the range for males. Therefore, the data for females has a greater spread. If you were to say the interquartile range and the range are X, and the interquartile range and the range for males is X, it doesn't really flow on too nicely. All right, compare apples with apples at the same time. All right. In 2018, Australian females had a life expectancy of 85.3 and Australian males had a life expectancy of 81.3. Explain what conclusion can be made about life expectancy of Australians in 2018 when compared with regions of the world. So compared to this table here that they give you, how do Australians stack up? Generally speaking, we are higher. All right. You would just have to look at the mean, median, like the mean, both. All right. We know that Australians in both categories have a higher life expectancy. Question 5. Okay, this is another one where some of us were kind of hit and miss. I feel like we did really well with the calculation side of things, but our explaining, all right, our reasoning for our decisions wasn't all quite there. So here you've got Oliver is researching the consumption of energy drinks by students at his school. One lunchtime, he stands in the canteen and asks students whether they have consumed energy drinks during the previous 7 days. 15 Year 9 students responded and shared that they had not consumed any energy drinks during the previous 7 days. Oliver submitted a report to the principal saying that none of the 725 students at his school consumed energy drinks. State 2 concerns with Oliver's sampling process. So here, Oliver's sampling process is neither random nor stratified. Okay, it's not random. He's not going up and picking random people. He's only picking 15 Year 9s at a specific location. All right, he's only sampling 1 year level. 1 year level does not necessarily reflect the whole school. I think you could look at that as in perspective this morning. Year 12s wearing pajamas to school does not mean that the whole school wears pajamas to school. All right. And then lastly, only those students attending the canteen had a chance to answer the survey. Some students might drink energy drinks and not attend the canteen. All right. And he's leaving that group of people out. The number of students in each year level is given in the table below. Here we are. Calculate the percentage of Year 9 students in the school. Some of us forgot how to calculate the percentage. All right. all we need to do is divide the total number of year 9s by the total number of students in the school. So 104 by 725, and you times it by 100% to get, or 100 to get that percentage, right? And that would give you 14.34%. Most of us, once we remembered that, we're able to do it right. But it's just some of these little things we can't forget how to do. State 1 sampling method, Oliver would be using if the percentages of students in each year level were reflected in the sample. Stratified sampling. That's the only one it is. Give 2 reasons why the sampling method used in stratified may improve the reliability of Oliver's results. Sample will represent all year levels of the school, not just year 9s, and each year level will be represented fairly. Okay, it's not just taking 10 of each year level; it's taking the true reflection of that group of students make up of the whole population. All right, on to stats. So the table below shows the number of countries in X and the number of athletes in Y that competed in selected Olympic Games between 1936 and 2016. All right, the scatter plot below is missing 1980 and 2004. Plot these data points on the scatter plot. Okay, one thing that a few of us did, all right, 2004 is 201. All right, some of us put it a little bit too far away from the 200, so we're just going to make sure when we're plotting our data, we are putting it in the right spot. That's really important. Okay. Calculate the coefficient of determination R squared and state the length. All right, this is where we go through, all right, and we pull up our graphics calculator and we put our number of countries in list 1 and our number of athletes in list 2, and we go through the process of actually calculating these. You go through graphing it and you create your own scatter plot in your calculator, and then you hit the calculate function and it'll pop up R squared. All right, and so equal 0.961, which is a very strong relationship. C, state why the data set for 1980 does not appear as an outlier. All right, although it's around here, if you have a look at 1980, there were a lot less countries than these two. But the reason why we don't discredit it is because it kind of fits the trend of the data, working in that positive upward trajectory. Calculate the equation for the least squares regression line of best fit. Write the equation in the place below. So that is asking you, so D is y equals ax plus b. Again, when you're on the screen, that gives you R squared. It will give you A and B. When you look here, y equals 49.8 times x plus 698. That's all it's asking you to do. In the 1900 Olympic Games, women were included in the competition for the first time, and a total of 997 athletes from 29 countries competed. State whether the least squares regression line, calculated in part D, gives a reasonable prediction for the number of athletes who competed in the 1900 Olympic Games. So here it's actually asking you to use, try and work out, well, how many athletes here were a part of it? Is that true? So 997 from 29 countries. It's trying to get you to state whether that's true. So you leave Y, you have 49.8 times 29, the number of countries, plus 698 will tell us that 2,142 athletes should have competed. That is incorrect. Okay, so I'm putting the least squares regression line into a bit of question there already. Next question is, it is widely accepted that the modern Olympic Games began in 1896. A total of 240 men and no women competed that year. Using the same least squares regression line formula, predict the number of countries that competed in the Olympic Games. This is a problem as well, all right? Because when we go through that calculation, 241 athletes, and go through this process, it actually gives us with a negative number of countries. All right, you need to say this is unrealistic because it's actually not possible for negative 9 countries to be competing in a game. There's no such thing as negative countries. Explain why it is unreasonable to assume that all data from the modern Olympic Games follows the same trend. Okay, Well, in E, we predicted that 2,142 athletes participated, when in actual fact it was only 997. And in F, it said that there were a negative number of countries attended, therefore it's unrealistic. That's all it's asking you. So if you have a look here, we're just using what we've calculated in the last two, how it kind of seems a bit strange. All right, E doesn't match what we've calculated, and F can't be possible. So that's why it is unreasonable. All right, question 7. This was our superannuation. Now, I know we covered this most recently, but this was probably something that a lot of people struggled with. Okay, where we started, we had here, Lola has a job in which she earns $125,000 per year. Her employer makes quarterly contributions of 9.5% into her superannuation fund. Most of us were able to do this part correctly. Times it by 0.095, and then you times that by 1/4, or you divide it by 4. All right. Where we started to struggle here was in this question, when it's asking you to show that the interest rate is 6.74. That's when it's asking you to find I. So if you have a look here on the answers, I is our question mark. All right. Your future value and your PMT are there. All right. PY, CY is 4. N is 20 times 4. 20 times 4. And then 500,000, that's our future value. All right. And it will actually spit out that I equals 6.74% per annum. Show that Lola's superannuation balance after 30 years will exceed $1 million. So this is where it's showing us, it wants us to show that our future value will be over $1 million. Okay? So again, if you look at the answers, our future value is the unknown. Now, all right, 30 times by 4 for N, putting all the other details in, and we see that the answer is like 1.14 million. Which is greater than $1 million. In 2020, Australians were allowed to withdraw money from their superannuation fund if they were under financial pressure. Lola chose to withdraw $20,000 after 20 years when she had $500,000 in the fund. Calculate Lola's new superannuation fund balance after 30 years. Okay, so after 20 years, we're taking out $20,000. All right. So that's why we go, all right, 480 is our present value, and we're going 10 times 4. So for the next 10 years between 20 and 30, so 10 times 4, our present value is 500,000 minus 20,000, 480, making the same payments per year, compound periods per year. All right, we're trying to focus on what the future value is. Okay, calculate the fund balance after 30 years. All right, and that shows us that Lola's balance after that time was 1.105 million, all right, or 1,105,852,000. All right, calculate the effect on Lola's balance when after 30 years, when $20,000 is withdrawn after 20 years. Okay, so what that is asking you is it will reduce. It's basically asking you, well, if she had left it as per usual, which is here, what's the difference between these two? That gives us 38,000. Explain why Lola's balance is reduced by more than 20,000. Okay, the principal has been reduced, therefore there is a reduced amount of interest being paid onto Lola's account. Select one or state one strategy Lola could use to minimize the impact of withdrawal 20,000. I mean, one thing, like the 3 things that we could do: increase her voluntary contribution, so pay more into the account, make a lump sum payment. So say if whatever she used that $20,000 for, she had some left over, she could dump that back in, or find a better return rate with another fund. Those are the 3 things she could have done to improve it. All right, question 8. I think question 8 stumped us when it shouldn't have. This is looking at simple interest, okay? And it's just giving us, this is how much we're earning, this is how much we invested, and I think the wording of it was kind of just what caught us out. All right, this is how long we put it in there for, so 18 months, which is 1.5 years. All right, and that's why we kind of struggled to find out what our rate was. Here, we've got 32.5% tax rate, calculate the tax she would pay on her investment. We're timesing that total amount, so the $275 of interest, by 32.5, the tax rate that she falls in. That gives us this number here of 89.38. Calculate Dakota's after-tax return. So the return on investment, so it equals 275, how much interest she earned, minus what the tax she paid on it was, 89.38. 185.63 was the return after-tax return. Show that Stephen's account earned 4.43 per annum if the interest was compounded weekly. So B is asking you to get your calculator out, go into the stats function, and go through this bit here. All right, where you go 52 times 1.5, and you go through that process. All right, it's compounded weekly, and that's how it's solving for I. It's showing that I equals this. Okay, so I is our question mark. Lastly, Yoko invested her $4,000 in an account that earned the same rate of interest as Stephen's, 4.43% per annum compounded weekly, but she also decided, well, I'm going to put $1 every week into her account. Calculate how many less weeks it took Yoko to accumulate 4,275. This is where we're trying to find N. How many less weeks? All right. N is our question mark. I is our interest rate. Present value payment is just $1 every week minus 1. A future value we know is 4,275. Payments per year and compounding periods per year of 52. Okay, so in that tells us that it took 60.8 weeks or 61 weeks to accumulate 4,275. Remember, sometimes where we get caught out is we think that that's the answer. No. How many less weeks did it take? We go 61 compared to what it took these guys. All right. What's the difference? It is 17. It took Yoko 17 less weeks than Stephen to accumulate that. And lastly, question 9. A government guaranteed home loan only requires a 5% deposit. News reports have suggested that the low deposit will allow first home buyers to get into the property market. Caleb is a first home buyer who wishes to purchase a home valued at $600,000. Show that Caleb would need to borrow $570,000 after paying a 5% deposit. Okay, deposit 5% of $600,000 equals $30,000. Therefore, Caleb would need to borrow $600,000 minus $30,000. And that's our answer. If Caleb repays the loan over 30 years, calculate his monthly repayments if the loan is 3.25% per annum, compounded monthly. Again, this is something that we've just done, and we all did this one really well. If you got up to this question, you generally got it right because it's quite fresh in our minds. All right, we're finding the payment, and we are still trying to. So this is what we're trying to find. It's what we've done recently. Future value is 0. Everything else is the same. Present value is minus 570,000. Therefore, once you punch that into your calculator, it will tell you this is what the repayments are. Caleb found another loan that required a 20% deposit. Using this loan, he would need to borrow $480,000. Calculate the time in years. Okay, so that time is N that it would take Caleb to repay this $480,000 loan if the repayments are $2,480 each month. Assume the loan remains the same at 3.25% per annum, compounded monthly. All right, we're finding N, which is here, punching all our data in as we know it. Solving for N, it would take Caleb 274.6 months or 275 months, which is 22 years and 11 months to repay the loan. One thing that I looked at and that I noted with all of us, we would just divide this by 12, all right, and it would tell us 22 years and 9 months. You need to make sure that before you do that, you round up because you can't pay 0.6 of a month. All right, you round up to 275 months and then you divide it. All right. D, for the loan calculate the interest Caleb would have calculate the interest Caleb would save by paying 20% rather than a 5% deposit. Okay, so for the 20% loan, these are our total repayments. All right, and the total interest paid is total repayments minus the principal, gives us 201,000. For the 5% deposit, times the total repayments by the number of repayments, then we minus the principal there. All right, so 320, and then when we want to find the difference, how much he saved, we take how much he would have paid with the 5% off of how much he would have paid in this. So he would have saved $122,000 in interest. Caleb would have to pay $120,000 deposit for the second loan. Discuss the reasonableness of Caleb choosing the option of paying 20% deposit instead of choosing the government guaranteed home loan. He'd have to pay $120,000 up front for the second loan, which may not be reasonable because he's a first home buyer. He's looking to get into the market soon. All right, he might not be able to come up with that $120,000 deposit compared to the $30,000 that he originally was allowed. So it might not be realistic. All right. Look, it's good. It's not all panic stations. We were rushed for time in that one. I think where we did well in certain areas and we were consistent. I think a lot of us did stats all well, but moving forward, we just got to make sure we're continuing to study and we just identify those areas we struggled in. And also, I'm going to stress it more than enough, more and more each week. All right. We got to read the question because I think that sometimes we just fall into the trap of thinking we know what the question is asking when we don't. All right. So that's it for me. I'm going to upload this and try and get it out. But well done. Let's keep it rolling. Later, skaters.